Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 1 to infinity, natural log of x divided by x dx. This is an improper integral, which we can see by the infinite limit of integration there. So by the definition, this should be equal to the limit as b goes to infinity, the integral from 1 to b, natural log of x divided by x dx. We could go over on the side and find an antiderivative to natural log of x over x dx by letting u equal the natural log of x. Du is then equal to 1 over x dx. Well, that's exactly what this integral is. The integral natural log of x 1 over x dx. We can write it just like that. And so our integral becomes the integral of u du. U squared over 2 plus c. U is equal to the natural log of x. So the natural log of x squared over 2 plus c. That's an antiderivative. It's the collection of all antiderivatives, but we really just need one. So our limit here becomes the limit as b goes to infinity of the natural log of x squared over 2 evaluated from 1 to b. So we evaluate by substituting in the upper limit of integration, which is b first. So the natural log of b squared over 2 minus, then you substitute in the lower limit of integration, which in this case is 1. And then we simplify and evaluate that limit. Well, first off, notice that the natural log of 1 is 0. 0 squared is 0. 0 divided by 2 is 0. So this back part is minus 0. Now, the natural log of b squared divided by 2. b is getting closer to infinity. That means it's getting larger and larger and larger. If you recall, the natural log function looks like this. So as the input gets larger, the natural log, which is the output, also gets larger. So as we move to the right on the graph continues to move upward. So that's going to say that the natural log of b, as b goes to infinity, the natural log of b is going to go to infinity. And if you just have a big number, a number that's getting closer to infinity, and you square it, it gets even larger. So that goes to infinity. Dividing by 2 does very little to change that. In fact, nothing really. So the limit becomes infinity. Subtracting 0, we still get infinity. So this tells us that our original improper integral from 1 to infinity, natural log of x over x dx, diverges.